Waterberg FM.
Good evening, grade 10 learners. My name is Mr. Chaza. I'm going to continue with functions, and today we're going to look at quadratic functions. Quadratic functions are functions of the form y is equals to ax squared plus q. Remember, last time we said you always have to start from the mother graph so that you see the form of this type of function. So for you to have the mother graph, obviously the value of q should be 0 and the value of a should be 1. So we are going to end up having the function y is equal to x squared. So this is the mother graph, y is equal to x squared. So we need to sketch this graph or to plot it. Remember, when you are plotting, it's more accurate than a sketch. So if you are having a graph paper or a grid paper, you can take your grid paper and let's have a table. The table should have your x values and you work out what is the y values. Let's start the x values from minus 2 up to 2. So we expect to have a row where you have the x values and your y values, the input and output values. So like I said, let's start from minus 2 up to 2. So we are having minus 2, minus 1, 0, 1, and 2. This is your input values, that is the x values. So to work out the output values, you are just going to substitute the input value into your function, which is y is equal to x squared. So if you substitute x, which is minus 2 squared, make sure you put bracket. Remember, it's minus 2 that is being squared, not a minus 2 then squared. You have to put in brackets like that so that your output value should be 4. Then when x is minus 1, your output value should be 1. When x is 0, your output value should be 0. When x is 1, it's just you are substituting where there's x, you are putting 1, so you are squaring 1, you are going to get 1. When x is 2, you are squaring 2, 2 squared is 4. Right, then we now have a table of values. Then let's now try to put it on a Cartesian plane. So let's draw the Cartesian plane where you have your x-axis and your y-axis. Remember, the vertical axis is the y-axis and the horizontal axis is the x-axis. Make sure you label the axis, the y-axis and the x-axis, and let's put in the numbers. Right, like we said, to the left, to the right of 0 is positive numbers, so you're going to have 1, 2, 3, 4. You can even end up at 4, there's no problem. But on the y-axis, make sure that 4 is there because the y values are ending up to 4. So it should be 1, 2, 3, 4. Remember, it's above 0, they are positive. Below 0, they are negative numbers. That is minus 1, minus 2, minus 3, maybe minus 4. And to the left of 0, remember, we have negative numbers, minus 1, minus 2, minus 3, and also minus 4. And now, like what we did last week, plotting, I think this time is not going to be difficult. It's just simply you are plotting the points on the Cartesian plane. The first point is minus 2, 4. So you go to minus 2, then you go to 4. Then where they meet, you should have a point with a dot or a cross. Then minus 1 is 1, minus 1, 1. Then 0, 0, 0, 0 is the origin. That is where the axes are intersecting. Then 1, 1 is 1, 1. And 2 is 4. When x is 2, y is 4. So they are meeting there. Right? And if you can see here, this line, these points are not in a straight line. So to join them, obviously you need to use freehand. And let's just join them using freehand. And if you join them nicely, you should end up with a function, which we call it quadratic function, and sometimes we call it parabolic function. So we are now having a function which is the mother of quadratic function, which is y is equal to x squared. And let's study this function. You see, this function is symmetrical about the line, about the y-axis, which is, in other words, it is symmetrical about the line x is equal to 0. Don't get confused. The line x is equal to 0 is the same as the y-axis. So it is symmetrical about the line x is equal to 0 or the y-axis. And it is also the arms, if you can see, it's like it's facing up. So the turning point, there's a turning point here which is at 0, 0. And so what this means is that this graph has a minimum turning point, or it concave what? Up. The arms are facing up, so it means it's concave up. So it has a minimum turning point. And if you can check, it's like it's someone who is smiling. That's why sometimes you see some books, they'll say it follows a smile. You know, if someone is smiling, it's like that. So the graph, we can say it's a smile, but it should be in quote because this is not a mathematical term. But if you say it has a minimum turning point, or you say concave up, then it is mathematical. Those ones are mathematical words. So we are saying it is symmetrical about the y-axis and it concave up. Right, let's check now when we change the value of q. So we are now going to look at the effect of q. Effect of q. And remember, for us to find the effect of q, we may need to just use the mother graph. We don't change a, we just change q. And because we don't have much time, we just want to use just one example in C. So we want to sketch the graph of y is equal to x squared plus 1. Y is equal to x squared plus 1. Remember, I have just changed q from what it was from the mother graph. It was 0, now it is 1. So now let's try to plot it. And to plot it, remember, you also need to add another row in sub. So it means you are saying minus 2 squared plus 1. And what are we going to get? 2x squared plus 1, you should get 5. So it means when x is minus 2, we are having 5. When x is minus 1, so just put, where there's x, put minus 1, then you square it, then plus 1, you should get what? 2. When x is 0, obvious y should be 1. When x is 1, y is going to be 2. And when x is 2, y is going to be 5. So in other words, that is the points. Then let's plot it. If we plot it, the first point is going to be minus 2, 5. So if you had end at 4 on your y-axis, please add another one, so that you go up to 5, so that you can accommodate that point. So it is minus 2, 5. I can plot it this. Then minus 1, 2, minus 1, 2. Then here I'm going to have 0, 1, 0, 1. Then 1, 2. 1, 2, then 2, 5, 2, 5. Then remember I said you still having there, it is still having a minimum turning point, and it is also still symmetrical about the y-axis. But what has changed here is the turning point. The turning point is now at 0, 1. So it means what has happened here? It has been shifted 1 unit up. So if it has shifted 1 unit up, it means that every point has been shifted 1 unit up. As you are seeing from, especially when you are looking at when x is 0, you see that it has been shifted 1 unit up. So it's just the effect of Q. We can conclude that the effect of Q is a vertical shift. Vertical shift. So if you remember, when you are saying vertical shift, you can either shift it upwards or downwards. So like we did with that straight line last week, you can either shift up or down. And in grade 10, we are just going to concentrate on the vertical shift up and down. When you are in grade 11 next year, then you can look at also sideways, the horizontal shift. So what does it mean? I can even sketch a graph of y is equals to x squared minus 1 by just shifting my mother graph, which is y is equal to x squared. In this case, there's a minus 1 here. I'm going to shift it down, which is by how many units? By 1 unit. So I'll shift it down by 1 unit, so that it should turn at minus 1. And remember, I'm guided by this one. It should be symmetrical about the y-axis, and it is going to turn at minus 1. Right, then remember there's the x-axis here, the x-intercept. That is where the graph and the x-axis intersect. We will look at it. How do you find that one? But this one, the effect of Q is just a vertical shift, and it is you just shift it by Q units. Remember, if it is 1, you shift it by 1 unit. If it is 2, you shift it by 2 units. That is the effect of Q. Right, let's quickly check the effect of A. Remember, for you to check the effect of A, you need also to draw the mother graph. Then we are now going to just maybe put Q at 0, so that you can have maybe something like this. And here we have changed the coefficient of x squared, and we have put minus 1. So it means we have changed the value of A. And you can even sketch the graph maybe to differentiate this one. Let's say this one is y1, and the other one, we can even draw the other one, which is 2x squared. So if we can sketch these graphs, then we can see the effect of what? Of A. Right, which means we still also need to have a table. Let's have the table. Your table you can even start also again from minus 2 up to say 2, your x value, and you have y, so if your y1 and your y2. Right, remember your y is the mother graph, which is x squared, and your y1 is minus x squared. Our input again starts from minus 2 up to 2. And let's work out. Remember, already we had the input values for the mother graph, which was 4, 1, then 0. When x is 0, it's 0. When y is 1, it's 1. When x is 2, then it's 4. Right, for y1, which is equal to, that is minus x squared, when x is minus 2, right, make sure, I don't want you to use a calculator here, just let's substitute correctly here. When x is minus 2, it means you are saying minus, then you put minus 2, then you square it, right? So what is it that you are going to have? You are going to have minus, then this one, minus 2 squared, remember is 4. So the answer should be minus 4. So when x is minus 2, the answer should be minus 4. When x is minus 1, we do the same thing. Whereas x put what? Minus 1. So it's minus and into minus 1 squared, which is going to give you minus 1. So when x is minus 1, it's minus 1. Then when x is 0, that one is going to also be 0. Then when x is 1, you are going to see that you are going to also going to have minus 1. When x is 2, you are going to also have minus 4. Right, let's also put this other one, or complete this other one, y2, which is equal to 2x squared. Right, when x is minus 2, which means, right, in this case, you are saying y is equal to 2, then you put minus 2, you square it. And so you are going to say minus 2 squared is 4. 4 times 2, it should be 8. Then when you say x is minus 1, you are going to have y is equal to 2 minus 1 squared, and minus 1 squared is 2. Sorry, minus 1 squared is 1 times 2 is 2. So you are going to have 2. When x is 0, you are going to have 0. When x is 1, you are going to have 2. When x is 2, you are going to have 4. Right, let's quickly sketch it, then, so that you see how this graph is going to be like. Right, the mother graph is going to be very easy to sketch because we have done it. Then the other ones, make sure, because y1 is having minus, the y values is from minus 4, if it's, yes, minus 4 up to 0. So make sure you include minus 4. So I'm going to put here minus 1, minus 2, minus 3, minus 4 below 0. Then up there, I should put 1, 2, 3, 4. It's not necessary to have many values. And I also need to label my axis, minus 3, minus 4. Right? Because I'm not having enough space, I may just leave 8. I will start from, for the other graph, that is y is equal to y2, which is equal to 2x squared. I will just start from, say, 2. Just have 2 values, two points here. Right, so let's start with the mother graph. Quick plotting of the mother graph. We'll see that at minus 2 is 4, and at minus 1, that is 1, and at 1 is 1, and at 2 is 4. Right, and I'll like this. Right, this one we have done it. Y is equal to x squared. Then that one of y1, which is equal to minus x squared, right, at minus 1, at minus 2, sorry, it's minus 4. I think this one I have it, so I can plot. At minus 1, it's minus 1. Remember, you go to minus 1 for x and y where they are meeting. At 0, it's 0. At 1, it's minus 1. At 2, that is minus 4. 2 is minus 4. So let's join the graph. It's going to be like that. Then your arrow goes down there. It means that the graph is continuing like that. y2. The y2, like I said, I don't have 8 here. 8 minus 2 is 8, but it's minus 1 is 2. Right, minus 1, 2. Then 0 is 0. At 1 is 2. Right, then it means that it's turning at 0, 0. This is the graph of y is equals to 2x squared. And this, the last one was y is equals to minus x squared. Right. Let's start these graphs one by one. Let's start with that one of y1, which is minus x squared. If you check, that graph is like it's facing down. Yes, we say that this graph has a maximum turning point. It's like someone who is wearing a hat, it faces down. Then from the mother graph, you see the mother graph is, let's say it's a grade 10 girl having a clay pot on top, right? So it faces up. Then the other one, which is y1, which is minus x squared, has a maximum turning point, faces down. So it's sometimes they refer to as a frown. So the frown is that it just faces down. So the graph faces down, or it's like someone wearing a hat. You see, that is the shape. So what is it that is happening here? From the mother graph, you see that the graph of y is equals to minus x squared. It's a reflection of the mother graph on the line, on the x-axis, or the line y is equals to 0. To get y is equals to minus x, just reflect the graph, the mother graph on the x-axis. Then, what about that one of y is equals to 2x squared? If you can see, this is like a stretch. It's like a stretch of the mother graph. The turning point remains the same, so you stretch it, so it is like a stretch of the mother graph. Y is equals to 2x is just like a stretch of the mother graph. So what does this mean? It means that the value of A determines how closeness of the arm of the parabola, these arms, to the y-axis. The larger the value of A, remember A here was 1, now it's now 2. The larger the value of A, the closer the arms are to the y-axis. Are we together here? I think we should be together, as you are seeing that. Then this one, like I said, it's a reflection. So what are we saying? We're saying if A is greater than 0, which means if A is positive, the graph we said it is a minimum turning point. Then if A is less than 0, which means if A is negative, we have seen that the graph has a maximum turning point. Don't worry about this maximum and minimum. What you just need to know is that it concave down and concave up. Minimum, it means concave up. Maximum, it means concave down. Or just think of smile and frown. Right. Sometimes you need not to plot, because sometimes they just want you to sketch. And remember, when you are sketching something, you need to just have important points. So we are looking at sketching. How do you sketch a quadratic function? When you are sketching, for example, you are sketching a human being, a head of a human being, what you need to just have is the head and the ears, the eyes, maybe in the mouth. That is the important parts of the head. Right, so just like this one, when you are sketching, you just need to check the sign of A. The sign of A. The sign of A determines whether the graph is concave up or concave down, or is maximum turning point or minimum turning point, like what I've explained there. And now the other thing that you need to look at is the y-intercept. Remember, y-intercept, x is 0. This is where the graph cuts the y-axis. And if you have seen those graphs that we have drawn, there is y-intercept there where the graph cuts the y-axis. And also x-intercept. Remember, y will be 0. And if you check the graph that I've drawn before, you'll see that there was this graph of, it's x squared minus 1. The graph passed through minus 1 and 1. So how do you do it? This is what we are going to do now. And you can also look at the turning point. Turning point. But this one is not important because, like we have seen there, the turning point is always the same as the y-axis because it is symmetrical about the y-axis. For grade 10, we are going to just concentrate on graphs that are symmetrical about the y-axis. Now, let's have a function. We want to have a function like this one. We want to sketch it. This is y is equals to x squared minus 9. Right, to sketch this function, like what we have said, check the sign of a. The sign of a, remember, a is the coefficient of x squared, which means in this case it's 1. And 1 is positive, so it means I'm expecting a graph which is facing up, or it's a smile. So I will say, okay, the first one should be smile, right? Then I'll go to y-intercept. I have to say y-intercept. Remember, x is 0. So I work it out. Y-intercept, x is 0. It means it's y is equal to 0 squared minus 9, which is going to be minus 9. And I can write it as a coordinate. It should be 0 minus 9. The y value is minus 9, and the x value here is here, which is x is equal to 0. Right, let's check the x-intercept. The x-intercept, we have said, is y is what? Is 0. So where this y, you are going to put 0. 0 is equals to x squared minus 9. Remember, you have done solving this quadratic functions, so you can solve it in different ways. Maybe you can just take this now. You can just add the additive inverse of minus 9. It's 9. So you say 0 plus 9 is equal to x squared minus 9 plus 9. So I'm going to have 9 is equal to x squared. Then you find square root both sides, which you are going to have plus or minus 3 is equal to x squared. Right. So we are going to have two coordinates of the y-intercept, which is going to be y-intercept, yes, 3 is 0. The y value is 0, and the x value is 3 or minus 3. So we are having two x-intercepts here. Like I said, the turning point is just going to be the same as the y-axis. So with these 3 points, we can sketch the graph. Let's quickly sketch it. You have your y-axis, the x-axis. Right, in this case, I'm having 3. I want 3, 0. So I want 2, 3, minus 1, minus 2, minus 3. Remember, I don't need even to have up to 9. I can just say straight 9. Here I want minus 9. I will just go down below 0. I can even just write minus 9. There's no problem that one. We don't penalize you for not writing the other numbers there. So let's plot these points. The points that